These wheels came off the wooden wagon project I did a few months ago. I didn't throw them away because I thought they might be useful for a project sometime in the future, and the time has come, I guess. Let's see if we can clean them up. I'm using citrus strip to get most of the old paint off. Now for some work with the wire wheel. Those don't look half bad if you ask me. Here's another piece from the wagon project that probably should have been thrown away. I'm plugging the bigger holes in this nasty piece of plywood with some dowels. I'm going to try to level off the roughest parts of this plywood with the electric planer. More smoothing with the electric belt sander. Here I'm using wood filler on the worst of the cracks and holes. And finally I'm using the palm sander for a last bit of smoothing. I'm putting a coat of sealer on this old piece of plywood. This is going to be the back for the battery cart. I'm making the axle brackets out of a scrap piece of 2x6 lumber. All of the wood used in this project is made from scrap wood I had laying around the garage. I made the axle from a length of 1/2-inch cold rolled steel. Here you can see the bottom shelf to support the battery. I used a couple of metal shelf brackets for added strength. making brackets for the cart handle. The handle itself will be made from a length of electrical conduit. I'm using the angle grinder with a cutoff wheel to cut the axle to length. Here I'm using push nuts to install the wheels and axle. You can see at this point that the cart has been painted black. I made some axle bushings out of a piece of PVC. Here's the finished battery cart with a 55 amp hour deep cycle battery on the bottom shelf. For this project, I'm going to need a couple of wooden boxes. These are going to be very simple boxes made out of scrap plywood with no fancy joinery of any kind. I've added some strips of wood inside the box to support the sheet metal control panel. The control panel is made from a repurposed steel computer case. I already had all of these components on hand. Almost all the DC connections will be made with Anderson power poles. Here I'm starting to prepare the control panel for mechanical assembly. Lots of holes to drill. I'm using chassis punches to punch the holes for the meters. I used a flap disc on the angle grinder to clean up the control panel. After painting and water slide decals, here's what the finished panel looks like. At this point, the mechanical assembly is complete and we're ready to start wiring. I used 12 gauge house wiring, which should be good for about 20 amps at 12 volts. That's way more than enough for this project. I had to make some spacers for the front panel because I didn't take into account the height of the power poles connecting to the power gate. Heavy mirror hangers were used to allow easy removal of the control panel box and the storage box. Oftentimes, problems can be solved by simply using a bigger hammer. After some stain and polyacrylic, it's time to attach the hardware. For this demonstration, I'm going to use a DC power supply connected to the AC mains to charge the battery and at the same time provide power to the load. The load is a 300 watt inverter powering a small fan. Observe that when the DC power supply is shut off, the fan keeps running because at this point it's running on the backup battery. Here the unit is powering an amateur radio transceiver. When the DC power supply is shut off, the radio continues operating on battery power. Here I'm using a solar panel and the solar charge controller to charge the battery and power the little inverter and fan. The solar panel is out of the frame and just sitting in a window. It should be much more efficient in direct sunlight. Here's the same setup with a solar panel powering a low-powered ham radio transceiver. Well, that's a wrap on this little project. I hope you enjoyed following along with me while I play in the garage. I really appreciate any likes and comments that you might have. Thanks for watching.